Well, thanks for coming out today. This is always, I think, the best part of what we can do is talk to everybody that works here at Johnson Space Center, our family and friends, because this is where really a major portion of the work is accomplished for a space shuttle flight. And we are happy to be here to tell you a little bit about it through our movie and slides. Before I do that, let me go ahead and introduce the crew real briefly. On my right is Terry Wilcutt, the pilot. Terry was a Marine Corps pilot and was from Kentucky, ended up being the first Kentuckian to fly in space. Next to him is Tom Jones, our payload commander. Tom flew on 59, the first flight of SRL, as you know, and was a very valuable member of our crew on this flight. Steve Smith is next to him. Steve was MS-1. He flew on his first space flight. Next to Steve is Dan Bursch. He's on his second flight. He flew as MS-2, our flight engineer. And on the end is Jeff Weisoff, who also flew his second flight on SRL-2 as MS-3. And with that, we'll just go ahead and start our movie, and we'll narrate it as it goes. The shuttle's sitting out on the launch pad during the nighttime as we're sleeping and getting ready, or some of us were sleeping. I guess the blue shift was up and about. They woke the red shift up about 5 hours before launch, which is fairly standard. We went in to have some breakfast, went to a weather briefing, and then immediately went in to get our suits on. Of course, in the suit room, we checked the suits for pressure integrity. There's Terry again, Tom, and he's the one in the orange suit. Steve and Dan. And Jeff. And of course, we take off from the crew quarters. It's a fairly standard scene, I guess. Jump on the Astrovan and head out to the pad where we get on board about 2.5 hours before launch. You'll see in just a second the water deluge coming down, the engines starting, and this time starting for good. A little twang, and again, when the solid rocket motors ignite, you're going out of town very quickly. It was a beautiful launch. Felt great on board. Jumped right up to 2.5 Gs. Did our roll maneuver, throttled down, and had a very, I guess, nominal ascent. No failures of any sort. It was very nice.
Here's the ascent, and the expression "we were kicked off the pad" is an accurate one. Here's a pretty spectacular view of us penetrating a cloud layer. During our ascent, you can see the reflection off the clouds. And the dark line off to the left there is, of course, the shadow from our exhaust plume. It took us 8.5 minutes to get to space. Here come the solid rockets being kicked off the ET. And if you watch carefully, you can see their exhaust tail off. And 8.5 minutes later, after liftoff, of course, we get rid of the ET tank and we're in space.
Next, we got the payload bay doors open, and Steve opened them up, and Dan took these pictures. You can see the port door going open, and it exposes the cargo bay and the Space Radar Lab to Earth for the first time. And the large slab-sided antenna is visible on the left. That's SIR-C. XR is the tilted, folded segment up against its upper right corner, and the MAPS carbon monoxide pollution sensor is on the bridge structure at the forward end of the bay. Now inside, we were activating ourselves too. We got all our cameras out. We had 14 cameras to document the radar science on board and the MAPS pollution science. There's a large Linhof mapping camera, and I'm holding a Hasselblad telephoto lens. We took about 14,000 shots to document the science on board.
In addition to taking a lot of pictures, we changed out tapes on board which recorded the data. This radar puts out enough information. It's like 45 TV channels broadcasting at once, and by the end of the flight we had enough data that could have equivalent to floppy disks stacked up 15 miles high, so it was quite amount of data that we brought back. One of the recorders failed in flight, so we had to change it out. This is the failed recorder getting ready to be put back under the floor.
Now the radar needed to be pointed while we were up there in the right direction to all the sites on the ground. Here I am typing in one of the 400 plus maneuvers that it took. Each shift ended up doing about 11,000 keystrokes. This is a view that we didn't see too often. About every 24 hours we had to point the star trackers, which are located on the nose of the shuttle, towards the stars to align our inertial measurement units on board. And here we are coasting down traveling southeast over India, the west coast of India.
Once we get the radar set up and ready to go, it's ready to start taking data. And the next scene that you're going to see is a picture of us passing over the Sahara Desert. As you can see, that to the eye, it doesn't look very like there are many features, but when you turn the radar on, this is what the radar can see underneath the ground, are ancient riverbeds. And that was part of our study. This was a geological site that we wanted to understand the history of how the Sahara Desert became what it is today, because obviously its climate in the past must have been very different to have these riverbeds underneath.
Now, we were looking into Earth's past history here in the Sahara, but we also got a chance to see some of the dynamic geology going on Earth. On launch day, the Khrushchevskoye volcano erupted up on Kamchatka, and you can see the ash and smoke plume going up over 50,000 feet here from this nadir view. You can even make out the lava flows going down the snow-covered sides of the volcano. And that ash plume was blown by the jet stream well out to the east, several hundred miles downstream. And the sight of this plume blowing downwind was really amazing each day when we came up over the horizon and saw this plume waiting for us over Kamchatka. And volcanoes were an important part of our studies on board. We were looking at 15 dangerous ones around the world that endanger populated areas. After a snowfall, Khrushchevskoye was almost pristine again. You couldn't even tell that it had erupted. But in our radar data here, you can see in this false color image the ash colored in red on the mountain slopes, and the lime green lava flow that was freshly generated during our flight coming downslope towards the Kamchatka River Valley. And I had actually brought up a small volcanic rock on board to give a little talk about our volcanic studies, and we hoped by unraveling the past eruptive histories of these mountains to tell you about the future hazards of them.
Well, we worked 24 hours around the clock up there, and this is 2 out of the 3 people on the blue shift, with Tom on the left, myself on the right, and Steve Smith is the one out of that picture. Here we are coming over Australia. It was clear, although several fires, and we would point out these fires and indicate when there were fires so the MAPS instrument could correlate that to their measurements of carbon monoxide that they were making. Here we are coming over the Philippine Islands, and this is 3 times normal speed, so we really don't go that fast. And you can see the reflections off the water. We can actually see several hundred feet beneath the surface because of what these internal waves do to the surface of the water. You can't detect with the naked eye, but you can with the reflections.
And to continue the blue team's explanation of what we saw here, I welcomed you to the rooftop of the world. That's what this area is called. This is Tibet. Even the valleys in this area are 15 to 20,000 feet above sea level. This was one of the beautiful sights we saw. The blue team saw the Earth lit from Europe all the way through New Zealand. This was always one of our personal favorites, to see the beautiful iceberg-colored lakes up in the Tibetan highlands. And you see off in the distance there is the Himalayas, and past that is India. As Tom said, we took 14,000 pictures. It kept us very busy. It was often a competition to get to any certain window. This is Dan looking out the commander's window. We were rolled slightly so the commander's window looked at Earth. It was always nice to be able to pass the cameras so easily. We always had time for a little bit of fun as we prepared our meals here. This is the way our meals were packed. This is me bringing up the lunch tray here and showing Tom and Dan what they could have. We often ate on the fly for lunch very quickly. We did have more time for dinner. Before we went to sleep, we often went downstairs, which we call the mid-deck. That's Dan eating dinner on the ceiling, me on the left, and Tom doing a last-minute film change before we went to sleep.
Well, everybody knows that Mike Baker's so cool, calm, and collect, it's really hard to spin him up, so this is the only way I've found on orbit to do it. Behind us there, you see the sleep bunks that we used. I couldn't quite get into it the same way that I learned as I was growing up, and it takes a while to practice to do it without banging your head too much. But it was nice to have those, and
Well, even though the shuttle was designed to be autonomous, you never can quite escape the ground, and nor would we want to. This is how we started every shift. We'd get a new attitude timeline, science timeline up from the ground, and changes to the flight plan. Like Dan said earlier, we had over 400 maneuvers we had to manually type in, and that equated to over 22,000 keystrokes. Every night pass, which was half our time up there, we would spend going over the flight plan, seeing what secondary activities we had to do, and also reviewing our onboard maps to study what land sites we were going to pass over. This upcoming scene, you'll be able to tell that this is a California pass because you can watch our commander get ready to take pictures of his home state.
You see it getting fairly excited here because we're getting ready to go over California. This is San Francisco Bay Area, San Jose. See the Sacramento area here, the Central Valley of California. Down here at the very bottom of the screen is Monterey Bay. And right in here somewhere is Fresno and Lemoore, where I'm from. At the top you can see the snow-capped Sierra Nevada mountains. And then pretty soon here you'll see this V is the San Andreas Fault and the Garlock Fault that come together right here. And right in there is Edwards Lake Bed. And then you'll be able to see Los Angeles and JPL, it's right in this area. San Diego right there. And at the top of the screen is the Salton Sea. And this light brown area you see in there is a large plankton bloom, a large agricultural area in the Colorado River Basin, and the Colorado River Delta that opens up into Baja. And of course on the bottom of the screen is the Baja California. And then you can see as we look back over the pass that we just made, you can see Baja extending off into the north.
In addition to passes down California that were spectacular, this is the Chesapeake Bay area. You can see Baltimore up here, and Washington's just going off the screen there. Here's Potomac coming up to the Washington area. This area is very important because it acts as a nursery for fish, and one of our prime sites was to study the Gulf Stream just off of the shore of eastern Virginia. And as we pass down here, you can now see Norfolk, Virginia, my hometown, and Albemarle Sound, and down here is Cape Hatteras, and of course Kitty Hawk, where the great adventure started, is just down there. So this is a nice view looking south, going off the coast, and just off the coast here would be the Gulf Stream area, which we would study in sunglint with our cameras. This is a picture of South America looking north along the Andes. This particular area here is what we used as kind of our visual aid in helping locate where we were. Coquimbo, Chile is right in that bight along the coast. And as you cross over the Andes here, it almost looks very three-dimensional. There were a number of mountains and volcanoes that were of interest as geology sites.
In addition to our mission to Planet Earth primary payloads, we also had several experiments in the crew cabin. Here I am setting up a 100-pound chair, which is very easy to manipulate in space, for a head and eye movement experiment. Here Terry has a laser mounted to his head, and he and I both did this experiment where we moved the laser to follow a target that was on the forward bulkhead. And again, it was to judge how well our eyes were working with our head movements. And we actually saw some degradation during space. That's the target on the forward bulkhead. We also had to do daily maintenance to clean out filters. Anything that's loose flying within the shuttle actually ends up on these filters as they draw the air to them. That's the commercial protein crystal growth experiment, growing crystals of an anti-cancer drug. So we just use gray tape to clean all those filters every day.
Well, here I am caught again playing with my food. Actually, if you'll watch this, you'll see some pretty interesting fluid dynamics. Of course, what I'm trying to do is keep that tropical punch off my shirt. Success. Here's an exercise period. Bakes and Jeff, if you look carefully, you'll notice that Bakes is the only one with an ergometer. And here's Jeff with a model of the Starship Enterprise and also a model of the shuttle. He took these up there because he knew that was the only thing Bakes and I were going to let him fly.
Here's Terry and I coming up to the flight deck to get ready to do one of the 14 trim burns that we did for the interferometry data takes towards the end of the mission. Dan put together a nice procedure along with the help of the FIDOs to get these burns trimmed down to an unprecedented accuracy of about 0.05 feet per second for the Delta V GOES. And we were able to successfully perform those burns and get the orbiter to within 200 feet of where it was the day before, and also within 200 feet of where the Endeavour was in April on the first flight of SRL. It's a pretty remarkable feat, I think. This is an example of what the acceleration of the Plus X jets will do to the folks on the middeck.
We put together the images from last April and October over Long Valley, California, an old volcanic crater in California, to make this three-dimensional topographic map, the whole objective of this interferometry experiment. And this is digital topography made from the radar without any contour elevations from the ground. Now, the radar was cooking throughout the whole 10 or 11 days of science, but eventually we started to run out of film. Here it is piling up, exposed in our storage bags on board. And when we ran down out of film, the radar was also running down its investigations. There's Mike and Jeff waving goodbye from the crew cabin. And while the sun was setting on SRL-2, we were also getting ourselves set up to come back for entry day, hopefully to Florida, but we wound up in California.
As you can see, we've turned our orbiting laboratory into a reentry vehicle and also an airplane. Jeff, on the right there, there's a shot towards Bakes. You see out the window the glow of the atmosphere as we start to re-enter, and the hot plasma gases as they come over the orbiter periodically meet at overhead and cause bright flashes. There's looking over Terry's shoulder on the right-hand side, the pilot, and you see the sunset there, and there's Bakes flying.
At this point, we take over manually at about 50,000 feet overhead the runway and fly it around the heading alignment cone. And here you see us turning on the final just prior to doing our subsonic DTO, or flight test. There's a little wing rock, which is about all the motion that you see out of the aileron doublet and yaw doublet that we did. We're coming down 18-degree glide path at 300 knots. At 2,000 feet, we performed the pre-flare to reduce our glide path to about 1.5 degrees. At 300 feet, Terry put the gear down. And we crossed the threshold at about 235 knots and 35 feet. Looking for a touchdown about 200. We touched down at 195, about 1 foot per second on the sync rate. And we were also doing the drag chute flight test, so we put the chute out immediately on main gear touchdown. Allowed it to fully deploy, and from touchdown to the start of derotation was about 15 knots. Started the derotation, got the nose on the ground about 130 knots, and started braking about 80 knots. And at 60 knots, you'll see in a second, we'll jettison the chute, and came to a stop about 12,000 feet down the runway with 3,000 feet remaining. It's a great flying machine. It was a joy to fly on this mission to planet Earth, and it was landing was a nice ending to a successful mission.
Great landing.
Thank you. We now have a set of slides to show you, and I guess, Tom, you can start off.
Well, this is our prime payload, SRL-2. And you're probably familiar somewhat with it already from last spring's flight. The large flat array of antennas is from the SIR-C element built by JPL, a synthetic aperture radar that includes both C and L band wavelengths. This tilting motorized portion up here is the X-band antenna built by the German and Italian space agencies. And both of these operated in concert at 3 different wavelengths to scan the Earth's environment at the surface. And looking at the atmosphere forward was the MAPS experiment on its 4th spaceflight aboard the shuttle, measurement of air pollution from satellites, which was designed to track sources and transport of carbon monoxide around the planet. It tells us about the carbon cycle and the input of trace gases that might be important to global warming. And Langley Research Center built this experiment, and it operated very successfully. Next. Now inside, while the instruments were doing their tasks under ground command, the crew was operating all its cameras full-time during the daylit passes. And here's Terry with all 4 of our Hasselblad cameras, each of which had a lens of a different focal length or film type. And here's the large Linhof mapping camera. We had 2 of those that were locked into a bracket pointing where the radar was. So in many cases, when we didn't have field teams on the Earth's surface documenting the truth of the radar's data, we had the cameras on board providing that ground truth to the science teams. So we were an important source of correlative or documentary information for the science to prove that the radar was giving accurate data to the scientists.
Well, as Tom mentioned, one of the important jobs we had was to try to document what the radar was looking at. This is myself in one of the aft overhead windows getting ready to use 2 of our Hasselblad cameras. Just to give you a feel as we go through these slides of kind of what you're looking at, this camera here with the 100mm lens typically had a field of view of about 66 nautical miles. So when you see some of those, you'll get an idea of the scale, whereas this lens here with the 250mm would zoom in to about a 26 nautical mile radius that you're looking at. And so we use these cameras as well as a wider angle camera to document most of the photographs. We also, as Tom mentioned, had a Linhof camera, which allowed us to get some wider format pictures as well. Next slide, please. Well, of course, you got to show your hometown. This is Norfolk, Virginia. One reason for showing it is up here is Langley, which was the sponsor of the MAPS instrument, which worked superbly all through the flight, monitoring the carbon monoxide around the world. Right here, you can see the ship piers along the Norfolk Naval Base. And as you come in here, you'd go up to the James River. This is the Elizabeth River that comes down to downtown Norfolk, and then the Lafayette River scoots off to the side here. If you go on out into the Chesapeake Bay area, you round this corner, which is Cape Henry, you'll go out along the Virginia Beach area and out, of course, to one of our super sites that I mentioned earlier, which is the Gulf Stream. And you could actually see the boundary of the Gulf Stream in the sun glint, because there's a difference in the texture of the water that you can see with the sun shining on it. Next slide, please. Well, this is a view of the northern part of the Chesapeake Bay area. You can see, of course, up here the Baltimore area, and as we come down from the Baltimore area, you can see the Annapolis area right in here, which I was told to mention by my commander. And, of course, down here was Pax Rivers area, and you have Washington, D.C. up here along the Potomac. And off in the distance here, you can see the Blue Ridge Mountain area. So this is really a nice clear day in Virginia and Maryland area. And as I mentioned earlier, this is, of course, a very important waterway. It's the home of the delicious blue crabs in the area, as well as a number of fish. And it's important for the marine life in that area that these wetlands are protected. And we were studying that entire region with our instruments on board. Next slide, please. This picture here is of California. This is Mono Lake here. And Crowley Lake is a small lake here. And one of our backup hydrology super sites was the Mammoth Mountain area, which is right here. Yosemite National Park is in the background here. You saw earlier the three-dimensional map that Tom talked about of the Long Valley area, and that was this ridge that extends along here. What happened was about 750,000 years ago, a volcano collapsed and created this depression. Now, one of the prime science objectives near the end of our mission was to do what was called interferometry. The way to think about this is when we took our normal radar pictures during the early part of the flight, that measures elevation a lot like a policeman measures how fast your car's going. It bounces radar waves off the ground and measures the time for the echo to come back. What interferometry does is it uses the same principles as those three-dimensional images you see on your credit cards called holograms. It actually interferes patterns of several multiple images, and you can use that to construct a three-dimensional image. Of course, here the challenge is we're trying to do it on a global scale as opposed to a small three-dimensional image that you see on your credit card. Next slide, please. This is actually a three-dimensional, this is a topographic map of that same area. This is Crowley Lake, the smaller lake that I showed you, and this is the ridge along here. And it's probably a little hard to see from your seats, but there are topographic lines on this map that show elevation changes for about every 50 feet of elevation change along that surface. Next slide, please. Well, there were two ways that we could actually do interferometry on our flight. One was to take images that were taken from the April flight, STS 59, and combine them with images taken from our flight. The other way, and that was how that previous map was made, the other way is to actually do passes over the same target within one flight, and that's what we did on the last few days of our flight, is we kept doing repeat orbits every 24 hours. This shows the data taken with the L-band part of the radar, which is 24 centimeters, and this shows a topographic image taken with the C-band, which is 6 centimeters, and what you'll notice is that the color changes are 4 times as fast for this one as for that, and that's because of the difference of 4 times in the wavelengths. So these images are basically the raw interference fringes taken from this part of the world, and they can be processed into a topographic map at a later time.
So we talked about earlier, this is the commander's window. Most of the photography that we took in support of the radar was out the overhead windows. The one Linhof you saw on the bracket was in the right aft window, and then the other window was used for handheld Hasselblad or Linhof pictures. But the commander's window looked in the opposite direction than the radar did, so you were able to take other photographic documentation of other things that are general Earth obs photography that's done on any flight. So that's kind of what we did out that window. And we also took pictures of radar sites depending on whether we had nose forward or nose aft going along our velocity vector. We may see radar sites on a different path than when we were actually using the radar to image it. This is just a photo of the tile damage we received on the right aft OMS pod, and I think that that this was caused by the tile that came off the overhead window on launch. This is a shot of San Francisco Bay. We have to point out a few things here. I guess we'll start off with downtown San Francisco and the Golden Gate Park, Golden Gate Bridge. Down south is just off the slide is San Jose. There's San Francisco International Airport. This island is Alameda. Right there's the Naval Air Station in Alameda. Oakland International Airport's over here. And here's Alcatraz Island and Angel Island and Sausalito. The other thing that's kind of interesting about this shot is you can see the San Andreas Fault that goes up here and extends across the bay up here. This is San Francisco at night. We had very nice night passes over San Francisco. And unfortunately, you know, we see most of the Earth, or 50% of our time looking at the Earth is at night. And it's really a beautiful thing to see. And unfortunately, there's not really a good way to show you what it looks like from Earth. It's very difficult to get good photography at night. But this one turned out okay. You can see the bridges in the San Francisco Bay here. San Mateo Bridge, this is the Dumbarton Bridge. And this is downtown San Francisco with the lights, the bright lights. And you can see the Bay Bridge and a little bit of lights from Treasure Island. And you can see the Golden Gate Bridge across there. This is a shot of northwest Canada, or actually south. It's just north of the Washington-Idaho border inside of Canada, and it's very typical of the northwest part of the country and of the hemisphere. And it's just an example of some of the things that we can see. You can see all these rectangular areas that you see all throughout the picture are a clear cutting of logs and timber in the northwest. And it's the very same thing that we see in Washington and Oregon and in the U.S. And the radar is very valuable if we had a permanent one at any rate to monitor these areas and see how they're recovering with their biomass.
This is a picture of me when Bakes was letting me sit in his seat. And of course, I've got the flight plan in my hand. It was interesting as a first-time flyer to realize that a day-night cycle does not define the normal day anymore. And with the flight plan, we use that as, of course, the coordinating document for all our activities, including our secondary experiments. And literally, the only thing that defined your day-to-day existence was that flight plan and the MET clock. This is a picture of Denver, and if you look carefully down here, if I can get this to work, that's the new airport, nicknamed the Land of Lost Luggage. This is Denver, and we showed this up here in the mountains above Denver. It's where the Great Plains meet the Front Range of the Rocky Mountains. We had a map site up there. There were 28 of the maps, and maps in this case, of course, is the measurement of air pollution from satellites. This is a picture we were lucky to get. Usually the light levels down this far south were too low, but fortunately we managed to get it. This is actually the country of Chile, and this is at the southern tip of South America, and what you're looking at here are a couple of glaciers. And I think our TV people are going to highlight this for the folks on video. Here's one of the glaciers here, and another one right down here. If you look carefully in the water, you'll see the icebergs actually being flaked off the inner calved off of these glaciers into the water. These glaciers also have these dark streaks through them, and that's boulders that have been entrained inside the glaciers as they move down the mountains. We study glaciers because we think we can detect movement, whether they're receding or progressing, and we believe this to be an important indicator of global climate change. This is the Panama Canal. This is Panama City, and the canal traces a path right through here. Notice the dark vegetation areas on either side of the canal. This is actually protected vegetation or woodlands, and one of the things we're worried about in Panama is encroaching development with Panama City right here. We're worried that, well, these are protected forests right now, but if they do develop in there and they log or harvest this timber, then the heavy rains that they receive in this area will flood down into the canal, and they'll actually fill it up with silt, and the canal will be useless. It's a perfect example of short-sightedness with a lot of human activities. If you fill up the canal with silt, obviously the country would lose a lot of its input there in money and capital. Also, the Smithsonian has a biological preserve located right in here, which is another reason to protect this area. This is a picture of the Sahara Desert. These are called the Tifernine Dunes, and it's difficult to see in this picture, but there are a lot of sand dunes in there, and scientists actually get a lot of information on wind currents from the direction and the shape of these dunes. And also, as stated previously, we imaged a lot of our targets and sites were in the Sahara Desert because we were imaging the subsurface drainage patterns from when the Sahara was a lot wetter place than it is now.
Well, it's time to tuck the red team into bed, and here's a shot of 3 of the 4 bunks that we fly. The bunks are really nice. They provide some sound insulation for us, as well as a place to display some of your banners. Some of the better banners come a little bit later in the flight. But anyways, these bunks, we did get to take some pictures here. These pictures are kind of unique in that they were backlit by some slave flashes that we have several photo TV people that help us train for taking all these photos, and we appreciate all your hard work. Next slide. And here's a chart that was helped us out. We needed a more detailed map to help us find some of these radar targets. And through the help of JPL and the flight data file people here at JSC, we developed these charts. And it was kind of like if anybody's familiar with a triptych, when you go on a trip through the U.S. here, you can find your orbit and find where you are. Well, this is what happens when you put a B-52 pilot and an A-6 bombardier navigator on the same shift. You argue about where you are. But actually, I was just we were trying to point out what would happen in the next orbit. But anyways, again, we worked in 2 shifts. And this is Tom, myself on the blue shift with Steve taking this picture for us. And the charts really helped us out. Next slide.
Well, back to our most spectacular probably site that we saw on the mission, the eruption of Kluchevskoye. On the blue shift, we were lucky enough to see this for about the first 4 or 5 days of the mission. This was our morning part of our work day coming over Kamchatka in northern Asia. So here you see a nice shot of the plume blowing well out to the east into the Pacific Ocean, pointing out all the ash and smoke coming from that single eruption. The companion mountains were also erupting, and you'll see that in the next close-up picture. This is Kluchevskoye in full eruption. This is the mountain of Kluchevskoye itself. The eruptive vent was on the northeast flank of the volcano, here in the shadow. And down to the south a little bit is Bezimiani, another volcano that was building a little lava dome, and there was some steam coming off of that plume, off of that mountain as well. And this was just a magnificent sight to watch this plume evolving day to day in the mission. And we turned the radar on this with some quick replanning on the ground science team's part and captured some good data about how a mountain actually changes during an eruption. Next. Later in the flight, the eruption calmed down and the actual outgassing stopped, but the mountain itself here is all covered with that dark ash that was coming out of the mountain a few days earlier. And then later, as you saw in the film, snow covered the entire scene and made this a brand new area again. But here's Kluchevskoye and Bezimiani to the south. This dormant volcano up here is called Shivaluk, another target for the radar. Next slide.
As Terry mentioned earlier with the film, we do receive messages every morning on our fax machine. This is our fax machine right here, basically, and I'm changing the paper out. Often when you look at a picture from the space shuttle, I encourage you to take time to kind of look and see what else you see in the background, and you can learn something from that. You'll notice I'm wearing 2 watches. Most of us wore 2 watches so that we could keep track not only of the mission elapsed time, but also what time it was back in Houston. On my right wrist, you've seen this device also on Dan's left wrist. It's one of our medical experiments on board. Through this little prism right here, it's actually measuring the light levels that we were exposed to and recording that within the silver box. And within the silver box, there is also accelerometers measuring our activity levels, particularly our activity levels while we're sleeping to measure our quality of our sleep. This experiment was designed basically to study how well the blue shift, we actually were working basically from 8 a.m. to 4 p.m. local time, how well we were sleep shifted. Also on the back, you'll see one of a little yellow package there. That's one of the tasty cakes that Tom brought from his Philadelphia roots. Next slide, please. As we mentioned in the film, we did change out one of the payload high rate recorders. It was very easy to do. We had thought it would take about 2 hours and ended up taking us about an hour and a half. Jeff and I had made a specific trip to the Kennedy Space Center to practice this in-flight maintenance procedure in case it occurred, and that turned out to be a very valuable trip. It just speaks volumes for the preparation that we had before the flight, and we'd like to thank all the folks who helped us in all aspects of training in order to prepare for the flight. Next slide, please. As I mentioned before, the blue team saw basically from Europe all the way through New Zealand. This is a picture of Australia, the eastern coast, just south of Cape York. One of the things that has been happening in Australia in recent months is a terrible drought, and several fires have been started by the very few thunderstorms they do get and lightning striking the trees. So much of Australia was suffering, unfortunately, from these natural fires. The other interesting thing about the fires we saw is that, I recall, one of our experiments was measuring carbon monoxide in the atmosphere. That was the measurement of air pollution from satellites experiment, or MAPS. So every time we saw a fire, we reported that so that the scientists would know that a producer of CO, which are the fires produce CO, was at our location, and they were able to analyze the data, and sure enough, the data showed that there was higher CO levels here. So fires are a big producer of CO in the world, and we noted them wherever we saw them. Next slide, please. What we have here in the picture right here on the left side of the screen for those of you at home is Mount Pinatubo. So this is the island of Luzon in the Philippines. You'll recall back in June of 1991, we had a terrible volcanic eruption in this area, displacing many families, and also Clark Air Force Base, the United States installation right here. You can look real close, you can see the runways was displaced. In this photo, what you see here, just let me orient you first of all, this is what is called Subic Bay on the west coast of Luzon. This is Manila Bay, excuse me, right down here, and from military history, this is the Bataan Peninsula you may have heard of. Manila City is right here, just peeking out from underneath these clouds at the tip of the bay here. Now, if you'll go back to Pinatubo, again, the crater is right here, and what you'll notice interrupting all this nice green and brown natural color are these very light-colored flows, and what those are where mud and ash has been washed down from the very steep slopes of Pinatubo and actually destroyed vegetation and in many cases communities with this mud flow, and we call these lahars. Now, the eruption itself also, as we know, had a major climate impact around the world and, of course, displaced many people here. If we'll go to the next slide now. Now, this are two images from the Space Radar Lab. The image on the left is from STS-59. The image on the right is from our flight, STS-68. So about 5 months have passed between these two flights. First, let's look at one of the images. Let's look at the image on the left. This is what we can produce using the radar. It shows the different elevations. You see the different colors here. This orange you see here is actually ash that's come from the crater right here. And so using the radar, you can get a real-time image of what is happening in any part of the world. Of course, it doesn't matter what the weather is. Now, it also, with the radar, you can take an image from one point in time and compare it with an image from another point in time and compare the differences. In this case, in this 5 months, and in particular 3 weeks before our flight, the Philippines were hit with some very dramatic monsoons. Their 1994 monsoon season hit, and those monsoons carried large amounts of dirt and ash down these lahars, and 80,000 people were displaced in that short amount of time by all this rainfall and the ensuing mud flows. If you look at this lahar right here, this mud flow right here, it's a fairly thin black line. Well, 5 months later, you can see how dramatically it's increased in size. So again, the radar can tell you something real time about what's going on, and then you can compare it for changes over time. Next slide, please. Well, here we are again at the roof of the world, as the Tibetan Plateau is called. Again, the dramatic lakes in this area alternating with the peaks. Again, the minimum altitude in this area is usually around 15 or 20,000 feet. This is Yamzo Yunko, is the name of this lake. Also, I'd like you to look at the Brahmaputra River here and notice how it meanders through the valley here. It's a very interesting ribbon effect that's visually spectacular. I'd also like to point out that on this tributary right up here in the upper left-hand corner of the picture, for those of you at home, is a city called Lhasa, and it's the traditional hometown for the Dalai Lama and the Tibetan culture. Next slide. This is a picture looking from China and a desert in China called the Taklamakan, that's right here, south all the way to India. So in between the Taklamakan desert here, where of course it's sand and very dry, You go through the Tibetan Plateau here, 15, 20,000 foot valleys, and the peaks get up in the 20, 25, 28,000 foot area. Through Kashmir on the right side of the screen here, some places you've heard about, Nepal, and over here is the Kingdom of Bhutan, all the way through to India. We studied several sites in this area for geographical reasons. Again, under the sand here are potential old river drainages, things like that to look at. Another interesting cultural aspect of this is right along the face of the mountains here is something called the Silk Trail. And in centuries ago, that's how China shipped things like silk and spices to the east, to the west, to Europe, just along this path right here. And Europe returned goods, things like armor, jewels, things like that. And every 50 or 100 miles along this Silk Trail, you'd have a little trading outpost, and that's how things slowly worked their way across here. As a side benefit to our study, because the radar can look beneath the sand, we might potentially see some kind of trails here or some evidence of these stations that were placed along the Silk Trail. Next slide.
Well, here I am looking up at Earth. You know, you always get the question, what's it look like to look down at our planet? Well, there is no real up or down when you're up there, and here I am using one of the many cameras out an overhead window. Next slide. This is a early morning shot of Moscow. We knew if we were passing over Moscow, it must be early in the blue shifts, time up. But I'll try to point out some of the things in the picture. I don't know if we can work on the focus on that shot or not. But right in the center there is a Kremlin. Up in this area, which several people in the audience right now have been before and may be going in the future, and we have many folks from JSC that are there right now, is Star City, where the Russian cosmonauts train. There's a complex not too far from this large runway where they actually do most of their training. Their large international airport is right here. This photograph is oriented with north at the top. This city, Moscow, is interesting. This part of the world people have inhabited for 2,000 years. Moscow itself is 750 years old, and this is the home to 8 million people, quite a large city. Next slide, please. This is in China, in an area called Alishan. This was a desertification site. This is an area where they actually irrigate, and this is the Yellow River here. It's highlighted in sun glint, as you can see. We call it the Yellow River. In China, it's known as the Huang Ho. And actually, we were trying to get several shots of this area because we were told that the Great Wall of China intersects right about in here, and it's off the bottom of the slide, unfortunately, but there's another area. So we're still taking a good, hard look at this shot. The Great Wall ran along the mountain front in an effort to keep out the Mongol invaders. Next slide. This is a 250 millimeter shot of the Mount Everest region, the highest point in the world. Mount Everest is right there in the middle of the shot. I wish we had some audio going when we went over Everest, because we just about went crazy, everybody with about 4 cameras in each hand trying to take pictures. The way we find Mount Everest, this shot is looking mostly to the south. There's irrigation towards the bottom of the photo, which kind of turns into a V, and then we know if you look along the eastern V at the end of it is Mount Everest, and that's how we found it there. The elevation of Mount Everest is about 29,000 feet, so almost 5 statute miles. Our elevation was about, or almost, I guess, 5 nautical miles. Our elevation, or our orbit, was 115 nautical miles, so that's the closest that we ever got to the Earth right there when we're actually in orbit. The next highest peak is called K2. It's located to the west, and its elevation is just over 28,000 feet, also in the Himalayas. There was a hydrology site here called Kumbha Himalaya that was not too far away, which we're interested in as well. Next shot. And after the blue shift is done, of course, it's our turn to get into the bunks. And there you see a picture of part of my family there, and as I said before, some of the better banners that would come out. Again, you see the actylooms that we had to wear throughout the flight. And it's kind of funny. My daughter is 7 weeks old, and I've noticed some of the things that a small baby does, and one of them is the reflex. And both Steve and I had when we were falling asleep, we had some reflexes every so often, where you kind of get startled. And so we, in the beginning of our sleep period, usually kept each other up by having a reflex and banging the side of the bunks here and keeping each other up. Next slide.
This is a shot of the Aurora Australis. It's Southern Lights. Is really quite incredible to me. One of the most spectacular things that we got to see on the flight. Being high inclination, we got far enough south to be able to see this. In the redshift, got to see the lights about on 3 revs just south of Australia. Really incredible things to see. You can see the entire, at least on 1 rev, the entire magnetic pole. And you can see, point out some more features here. You can see the Earth's limb right here, the top of the atmosphere up here, and you can see the lights extending up way above that. And in fact, on some of the revs, when we actually went through or appeared to go through the lights. And then, of course, one of my favorite things to see on orbit are sunsets and sunrises, and they occur about every 45 minutes, and just fantastic, beautiful blues that you can see here. And with that, we'll go ahead and close our little slideshow.